Okay. So here we are. I've got my editor. Again, you can use whatever you like. This is just my preference. It's completely up to you what you use. Although I will say I've noticed that some people using some editors struggle with the tabs and spaces. Just stick to one. Okay. Some editors will take care of it for you. Some of them you have to actually stick to one, and so like I press tab and it puts 4 spaces in for me. Some editors won't do that. They'll put a tab in, and if you press space, it puts space in. So which is I suppose what they're supposed to do, but it's helpful sometimes to do that. Okay, so the first thing we're going to do is just make sure that everyone knows that we've got the assessment here, which explains all of the coursework, and this is in the assessment part of the website. And we've also got in projects the detailed description of the technical aspects. So the project part doesn't talk about it particularly as coursework, but it is the same thing. Okay, this is just the project, and the idea is that someone wanting to learn this stuff can come in and do all of these projects, even if they're not on the module. Okay, you can do these things whenever. But if you're on the module, you're going to be assessed on these two at certain points. So they're kind of kept separate. Okay, now this explains that there are a few things that you need to do. So it tells you the task, basic task, intermediate task, and advanced task. And it also gives you links to the page that has all of the binaries in it, with a little bit of an explanation about what each of them do, what each group does, and another link to the repository. Here we go, in the Brute Camel repository. Okay, so we'll open both of those up. Here's the repository. What we're going to do first of all is we're going to make our own copy of this repository. All right, so the way we're going to do that is not with a fork this time. We're going to do this using a template, and the reason is if we fork it, we'll end up with a public fork, and we want to keep our coursework private. So we're going to use this template, which allows us to make a clone of this that we can then use. Right, so click use this template. You fill in the repository name, and you can call this whatever you like. I would suggest that you pick a sensible name. I like puns in the names of things. So as you can tell, that's not a requirement. You don't lose or gain marks depending on how good your puns are. Unfortunately, I did check. I'm not allowed to. But you put something in. So we had Brute Campbell. I had I've told you before, a different project called Brute Forsyth, but I'm just going to choose to pick that. That's available. It suggests I use redesigned Barnacle, but it really doesn't matter. Just something sensible, right? Now you might just go for Brute Force. Yep, nothing wrong with that. Makes a lot of sense actually. Okay, you make sure it's private, and then you create the repository from template. Give it a moment. And there we go. What this has done is it's cloned everything from one place to another. Or clone is probably not the right word. It is the right word, but in context, it has special meanings as well. So it's made a duplicate of this repository. This is now my private one. Okay, and you can see that it's private. It says so up here. It's got this little lock next to it. It tells you where it's generated from. It's no longer a fork of it. It's generated from there, and we're ready to go. Okay, in here you've got the read basic, and there's some empty bits. This is sort of if you talked a little bit about templates earlier, I said there wasn't really a template for the report. This is as close as it gets, I suppose, because I expect to see some user documentation. I expect to see the list of unit tests that you're going to run, and I expect you to talk a little bit about the algorithms that you use to solve it. So how did you make all of those numbers? How did you do this? What was your approach? In words. So you have all of the contents. And now all we need to do is to get a copy of it on our local machine. Okay, so we can go through here. Like I said before, use the HTTPS unless you set up SSH keys. For now, don't worry about setting up SSH keys. I will actually put together a video at some point showing you how to do that. It's a slightly more convenient way, but it's barely any difference. So here you've got a link. You copy this, and we go into our shell. We decide where we're going to put our stuff. I would suggest that you have like a coursework directory. So I'll call it coursework, and I'll go into coursework. So make the coursework, go into coursework, and I'm going to make a coursework 1 directory, and I'm going to go in there. Right, so I'm being nice and neat and organized. Usually you see me make files all over the place, and that's because I'm really just doing stuff for demos. This whole virtual machine is only here for me to do demos in. It's not really anything I care about, but you should be tidier than I am when I'm doing demos. So for coursework, things like that, this is how I would do it. Now we type git clone and the URL that we had. That's not the whole URL. Try again. The URL that we had from there, which should be that one. Also managed to grab some junk. That's a bit weird. Okay, so there it is. It's copied from over here. You can see the whole thing. If you struggle with it, one thing you can do is you can just put it into URL bar and just check you can see the whole thing. Make sure you've got it, and you can paste it in. So do that. Press enter, and it goes in. It'll ask you for your username, your university username and password, which I'm going to have to type. There we go. And now it's cloned everything there. If I use ls, I've now got a folder called brute force coursework, because that's what I called the repository when I made that duplicate. So I go into brute force coursework using cd, ls to show me the files that are there, and I can see all of these things. Now, if I do ls-l, you can see that here I do have execute privileges on download target, because you can see the X in here. For some of you, I've noticed that for some reason you don't. I don't know whether that's the way you've got the stuff set up, or whether it's because this is cloned from my repository, it's kept my preferences on these things. I don't know. Some people have it, some people don't. I don't know whether people are accidentally undoing it. But regardless, it's really easy to fix. All you do, if you don't have those privileges, is you do chmod u plus x, sorry, plus x, and then the name of the script, which is targets.sh. Okay, now I've made my text very big so it's nice and clear on videos, but you can see it just goes on to the next line. So just be aware that's not download targets, it's download targets.sh. It's just down here. Press enter, and you should now have an X in here. I had it already, but I'm going through it just to make sure that everyone gets it. Now you can see there's a directory called targets in here. Remember, you can tell it's a directory in the VM. They're set to have color, so you can see blue is a directory, green is something I can execute. But if you were looking at this in something that doesn't use color, then you've got the D and the X, which tell you about it. So this is a directory, it's called target. And I look at targets, and I realize that it's empty. Okay, now I want to put all of the targets that I'm going to use into there, and rather than have you download them one by one, because I am so lazy, I didn't just, it was just me that I wanted to not have to do that. I also couldn't stand everyone else having to click on 9 things. Okay, so that's I'm lazy on everyone's behalf. So go and run download target. So / because it's here. And we talked a lot about paths and why you need to do that on Unix systems before. So download targets / download targets, and that will run a curl program to pull all of those things down. So if you're interested, you can look inside. I'm not going to go into it now. I am just going to click this to stop it flashing now. But all it's done is it's filled in. So I'm going to use ls targets, and you can see it's put all of these things in, and they're also green, and that's important. If they're not green, we use chmod. If it turned out that for some reason on your system, you might not be using mine, you might have different permissions set. If they're not green, and by that if you use ls-l, that means you wouldn't have this X. Okay, so if you're on a system that's not in color, you would use ls-l and look for the X in this column. If you don't have that, you would just type chmod u plus x target. Okay? In fact, what I'll do is I will do here a plus x, because you can see at the moment only I can execute, no one else can. And if I do a plus x and then have a look, you can now see that everyone can execute. Okay, so that's chmod. And there we have those things. And what I would do at this point, I would test that these things actually work. So how do I run them? I give the path and the file name, and that's it. So / targets. Let's go for basic1. Basic1 pops up with a little bit of ASCII art, and what it's actually doing is it's telling you the answer. It's 026. Okay, so there it runs. And if I run it with the wrong pin, we get password incorrect. Each of the groups of targets, so basic, intermediate, and advanced, the first one of them, the one that ends with a 1, will tell you the password. And the reason for this is it allows you to debug your code easily. So what I mean by debug your code in this case is if you run it and you know that the guess you generated included 026, but it still didn't work, you know you've got something wrong. If you didn't know what the password was, you would find it harder to know, well, do I definitely have the right password? Have I made a mistake? Whereas you can actually test this to make sure you've got 026. Okay, so now we're going to look at code. And before we do that, we need to make sure that we set up a virtual environment. This is the local copy of the Python binary, the interpreter, and the libraries that we need, so that when we're developing this piece of code, we have all of the things that we want. And if we take this to another machine, we don't rely on that machine also having the right things installed. They can be installed inside the virtual environment whenever you need them. So I've given you a makefile, which will help you do all of these things. Sorry, go back into the right directory. So I'm inside brute force coursework. This is what I call my repo. And you can see that's where I am. It's in there with the dictionaries, the makefile, and everything else. The makefile will allow you to make the virtual environment. Quick tip, I've mentioned it before, but I'm going to keep stressing this because, again, I want you all to get as lazy as I am and you move around as quickly as I do. Tab will do tab completion on lots of things. And because we're using Z shell, we get quite advanced tab completion. And if I just type make and press space and then press tab, it will actually show me all of the things that make knows how to do. Some of them you don't need to use, they're used internally. But the ones that we do want are, firstly, make venv. Okay, so let's do that. Make venv. This will now create a new directory. So you can see the name of it here, brute venv. If I do it ls, we now have this extra directory. It wasn't there before. And you can see here's before. Here is after. You can see there's the extra. And inside there will be a new Python interpreter and everything else. But for us to make use of it, we have to activate it. And we do that with a dot slash brute venv. So in this case, that's what it's called. In other cases, it could be called something different, but we called it that. Bin activate. Press enter. And you'll notice here, we have a little extra bit of information on our prompt line. Okay, now it's got quite long, and that's a little bit unhelpful in such a large font. But you can see it's useful because it tells us that we're inside that virtual environment. If I had another instance of this terminal up, see, I know here that I'm definitely not inside that virtual environment. Here, I'm definitely inside that virtual environment. Now, the next thing we need to do is to make sure we have all the libraries that we want. We know that we've already got Python installed, so if I did which Python, it tells me that we're going to be running Python from inside that virtual environment. You can see it in the path. Whereas, again, if I had a terminal that wasn't using the virtual environment and I type which Python, it will tell me that it's running system Python. But that means that this Python, this one inside the venv, doesn't have any libraries installed yet. Okay, so even if you have pexpect or pdoc or all the other things that you might want installed on your system, they might not be installed here. We need to make sure they are. Again, the makefile has something that can help. The one that we want this time is prereqs, and that will install those things for us. Okay, so make prereqs and give it a moment. It downloads and installs stuff. There we go. Okay, so I'm just going to clear the screen because it's not really interesting to see all of that random text. But now we have those things installed. The first thing you can do now is you should test to make sure that the binary, the boilerplate code works, the stuff that I gave you works, because each one of them is a sort of functioning program. It just isn't complete. So /src brute basic NU. Okay, so it's all written in for you. This all comes as default. We press 0, and we can see it tries 5 guesses, 000 to 004. and none of them help. And we could do that with you know, the other one, it tries that one, and so on. So we can check that works. We can also try you know, the other ones if we want to. So brute intermediate, and we can see, yeah, that one works as well. And it tries a bunch of words, but they're not the right words. So it's not going to find anything, but we can tell that it's working. Okay, so that is now us set up. We are ready to roll. We've got everything there. We know any changes we make, if they cause an error, we know that that's something that we've done, because at this point we had a clean repo. We did everything before we started changing code, and we can see everything works as it should do. So where do we change code? What code do we change? Well, you have choices. Some people, and a few people have done this, they've done it completely without my code, and good luck to them, that's fine, not a problem. Most people won't want to do that, okay? Remember that this is introductory programming, so although we're doing a brute force program, which sounds really complicated, your contribution to this is only going to be first year programming level, okay? So just be aware of that. If you feel like it seems like a scary prospect, remember it's not going to be that difficult. Okay, so in our editor, we go to the source file. So I'm going to go to what's it called? Coursework 1, brute force coursework, src, brute basic. Okay, and we can see here that we've got a bunch of code that's already there for us, and it gives us a bit of documentation. In the comments, it says this is a starting point for your project. Most of the work is done for the basic task. Intermediate will require reading from a dictionary file and created the advanced task, see the supporting a module brute time. Okay, actually you don't need the brute time. I incorporated it all in. I shouldn't remove that comment officially, but I'll get that later. Okay, so what have we got? Well, you can read through how this stuff works, or you can, if you're not sure that you want to, because maybe you think this looks a bit complicated, you could start by just looking at the comments and realize that here, this is where you need to put stuff in. Okay, here the guesses are listed explicitly. We could write out 1,000 guesses, but the point is to use a computer. For the basic task, the only functionality you need is to replace the line below with the code that can generate all the potential guesses. So it's really clearly saying this is the bit that you need to change. It's going to be just in here. It also needs finishing, testing, and documentation. So remember, you're getting marks for testing and documentation as well. Well, this is where you do it. Everything else is already documented. This is nice and clear. You need to do this part. If you make any other functions, you need to test and document those. But for the basic task, you definitely don't need to do that. In fact, you don't need to do that for the intermediate either. But if you want to, if it's how you want to implement it, that's fine. Okay. Now, the other thing that I would do at this point is, okay, well, I can see these things are here. I would look through the rest of the code. I can see we've got something called break binary, and we can read the documentation. Break into the given target binary, assumes the basic level binary with pin codes of 00. Okay, that makes sense. We look, it's got arguments. That's this list of information we have to give it. The three things it needs to take are the target, the prompt text, and the text. And the reason for that is because we say, right, I want you to, the target is the binary. We want you to break into it. You need to know when you're going to be expected to type in a guess. Okay, so it's when it goes enter the password, or what is the secret code, or whatever it is that's important. So whatever it is that flags up. And the fail text, we need to tell it because it needs to know when it gets it wrong. So that'll be something like password incorrect or whatever. And the reason we have that is because we need it to be able to spot when these things don't work. Okay, so once you get to this point, you expect it to be able to say, right, I've run the program and I see this fail text. It says password incorrect. That means that was a bad guess. If I don't see that, that must be a good guess. Now, in here, you can see the first thing this method does is it creates, or this function does, is it gets a list of guesses from this function here, which is the one you're going to fill in. And that's how these are linked. Okay, you don't need to edit down here. You only need to change this to get this right, but it's useful to see where it goes. Now let's look at how it actually does it. For G in guesses, well, guesses is a list. So for G in guesses means we're going to make G equal to each item in that list in turn and go around the loop. Okay, so B equals binary target, B.run, success equals B.attempt, prompt xg file text. These three lines are actually running and trying a guess. Okay, so G being the guess, it puts it into this method attempt, this function attempt here, and it says, right, when you see this, enter this and check to see if you find that. Okay, all of this comes from the Brutus library, which is imported up here, and you definitely don't need to look in that one. Okay, you are absolutely welcome to do it, but that is where all the complex stuff is, right? The actual stuff that's really difficult. Okay, you don't need to see. In the same way, you don't look at how Python implements all of its functions. So then we say if it's successful, so if we get a true returned, we just print out that seems to be correct. Otherwise, we say password incorrect. And if we go through all of it, then we return none because we didn't find anything. The reason we don't have to have a break is because of this return here. It will get out of this function with this correct guess. Down here, here's this comment that we talked about earlier. Create a simple menu system. So all I've done is I've said, right, the targets is an empty list. And then for each one, I've put in another little list which has got the path to the binary, the prompts that we expect. So the prompt that we expect when we enter it and what we see if we don't get it right. And so you can see they're all different. Yeah. Okay. Now we have print basic binary breaker. That's just prints an output. Then it prints out the menu and it says, right, which one do you want? And then it passes all of this stuff into break binary. And that's it. That's the whole program. That's all the stuff that you need. Now, what you're going to want to do is you want to check, first of all, that what you've been given definitely works. So we've checked to make sure that, our binaries work, but have we checked to make sure that, the functions work? Well, that's where we can use make test. Okay, and make test should collect up the tests and they should all pass unless you change something. Okay, so at this point, we've tested these things and we'll look at the testing in a moment. And we should also look at the documentation. So let's make docs. And the only one it runs for HTML documentation is Brutus because all of the others are just code that you're using. You don't necessarily need to have them as HTML. If you want to, you can easily just add to this make file on this line about which one it runs on. I wouldn't recommend, no need to do it. It's not part of the thing. The documentation can be viewed. You still write it. You just don't generate HTML. But let's have a look at the HTML since we're here. So file, you can type Firefox and open, or you can use lots of ways you can get there, but I'm just going to type in, actually no, I'll run it from here. That's the easier way to show you. Firefox, HTML, and Brutus.html. Okay, so it's Firefox, HTML / Brutus.html, because that's where the output to the stuff goes. It tells you on here. Press enter, and here we see module Brutus, and you can see, oh look, that's that binary. There's the attempt. Okay, so if you want to know what it does, this is where I would look. What I wouldn't suggest is trying to understand it from the code because some of it is a bit nasty, all right? Just because it's complicated to do some of the things that we've done. Okay, so we can see that those things work. We can see the things here. Let's just see what happens. Let's say we make a modification and we do this, okay? We add a new thing. This is not the answer. This is going to let us break into the first binary because we do know the password, and it's a good test to make sure that if we did have the correct password in the list, is it going to work? So let's just save that. Then over in our terminal, we're now going to run that basic program again. So /src brute basic. I want to break into basic 1, press 0. Oh, look, it did work. It could tell that 026 was correct. Okay, right. Now make test just to check everything. Now one of the tests fails, and the reason is we look at our tests, because remember you're going to have to update these tests to suit. We have in there test basic and then test Brutus and test maxpos. The only one you need to worry about at the moment is test basic. There we go in, and you can see here is the test that failed, and the reason it fails is because it uses the generate guesses function and it checks to see if the length is 5. Well, we just added to it, so we could fix this by making it 6. Okay. Okay, now it passes, but it's not really useful because that isn't the correct answer. what I would suggest is that one of your tests is to check that the length is the correct length. Now, you should know that when you get this test, this guest generator function correct, how many different pins it's going to have. And so I don't really give a lot away by saying that one of the tests that you probably want is this. And you can keep running that test with make test to make sure that when you think you've got the guest generator right, it is going to give you the right thing. The other thing that you might do is, I'm just going to put it back down to 6 at the moment, which I think was the right one. Yeah. For now, I'm just going to add another test in here that's a little bit of a fake test, but is going to help us test things out. I'm going to assert that brute basic generate guesses, whatever comes is going to have in it. Okay. Does that make sense? So I'm saying that the string 026 must be in whatever this comes out with. And now when I run our tests, it passes. If we go back to the code and we didn't have that in, so let's say we put 021, we should find that test fails. So these tests are really just making sure that we have something correct in there. And you can see, this didn't work. I was looking for 026 and what I got was 0001 and 021. So you can see where the error is. Okay. And from there, really your job now is to actually write your code and make it work. While you're doing it, you're going to want to be checking things into the repository and making sure that you actually have the changes recorded and they're all going to the right place. And we're going to do that really simply. We're going to go over to here, and let's say at the moment I've got a small change and I want to keep it. Obviously, it's a very minor change at the moment, but I can do git status. I can see I've changed 2 things, which makes sense. So the 2 things I've changed, the test and the source file that's being tested. Perfectly sensible. So now I'm going to check those things in. So git add source, brute basic, and also test basic. Okay, so I've put 2 file names on the end, press enter. Now do git status, and you can see these 2 things have been modified. Okay, but they're now green because they are to be committed. So I can now say, okay, good, I'm going to commit that. So git commit -m, and then inside quotes we can put the commit message. This is the note that goes into the repository to say what we've done. And I'm going to say did some minor work on basic task. Okay, it's I wouldn't normally check in something so small, but there we go. Okay, good. Git status now tells us that everything's clean. If I go into my browser and look at my version of this, I can actually look inside source. I can look inside brute basic, and I will see that it's not there yet. Okay. And why is it not there? Well, my local repository has it, but I haven't told it to make sure that that's mirrored on the remote repository. And to do that, I just type git push. Okay, username, password. Give it a moment to actually send it. There we go. Let me just get rid of pop-ups. There we go. And then over here, if I refresh this, you can now see that I've got that change. Okay, it's recorded. And if I just go back to the main repository page, you can see that the last thing 1 minute ago, these 2 directories were changed in some way, and they were changed when I did some minor work on the basic task. And that is possibly the slowest I could go through on those. Hopefully that gives everyone a good overview of how to get started and something can be replicated. I'm going to stop recording now.